So in the last lecture, we have seen various terminologies related to gears. That is, what are various definitions like pitch circle, pitch point, pressure angle, addendum, dedendum, clearance, phase, flank, gear ratio, velocity ratio, and etc. So today we are going to see law of gearing and characteristics of involute and cycloidal action. So first we'll start with law of gearing. So what is law of gearing? So law of gearing, what is the law? So to understand the theory, consider the portions of two gear teeth, let's say gear 1 and gear 2. So the two teeth come in contact at point C. So suppose, let me draw this. This is suppose gear 1, and this is suppose gear 2. So this is the teeth of gear 1 and this is the teeth of gear 2. Now they are coming in point of contact at C. So and the direction of rotation of gear 1 is anti-clockwise. So the direction of rotation of this gear 1, so this is gear 1, and the second is gear 2. So suppose one rotation is anti-clockwise and another is clockwise. So gear 1 rotation is anti-clockwise and gear 2 is clockwise. So now let TT be the common tangent between this. So let me draw a tangent here, and this tangent I am naming it TT, and let NN be the common normal here. So this line 90-degree to tangent will be the NN, that is normal to the tangent. So to the curve at the point of contact C. So this is the point of contact C. So from points now here, uh, let me draw O and O2, so that O1 and O1A and O2B be the perpendicular common normal NN. So suppose this is a gear, and its center is at some point here of gear 1, so that is O1, and this gear center is at somewhere here, that is suppose O2. So now what we'll do from O1 and O2 is that we will draw O1A and O2B perpendicular to the common normal NN. So perpendicular to this, we'll draw this O1A. So suppose this is the line here. So suppose this is the line NN. So 90-degree, this 90-degree O1A and O2B here. So this will all be a 90-degree. So perpendicular to common normal NN. So when the point D is considered on gear 1, the point C moves in the direction of CD. So now where is here D? Where it is the where the point D exists. So here we are going to give velocity vector for this gear and this gear. So the velocity vector for the first gear is suppose that is v1 in this direction, so that is v1, and velocity vector for the second gear is that is v2. So this is v2, and if I draw a perpendicular line here, so this point we will call as E and this point we will call as D. Now the angle subtending for velocity vector 1, that we will call it as alpha, and for velocity vector 2, that we will call it as theta. So here uh, the relative motion between the two surfaces. That is, so the law of gearing states that the relative motion between the two surfaces along the common normal nn must be equal to 0 in order to avoid separation. So in order to avoid that these two will not separate, so the relative motion between the two surfaces along the common normal nn must be equal to 0. So that is v1 cos alpha v1 cos alpha must be equal to v2 cos theta. So what does this mean? So this v1 cos alpha and v2 cos theta, so this both must be equal, should be equal. So now v is a linear velocity. If I want to convert into angular velocity, so we know the relation, that is v is equal to omega r. So instead of v we will use omega r. Now here v1 we are using v1, so the related angular velocity will be omega 1 and r. So what is the r here? So r here is OC. So here r is OC, and here for second vector, that is r2, it is o1 o12, sorry, o1c. So this is o1c, this is r, and this is o2c, so this is the r. So this is the o1c and o2c, so that is the r here. So that is radius. So that is what is the radius of the gear. So we know that radius is o1c and o2c. So here it will be into o1c into cos alpha is equal to omega 2 o2c cos theta. So but from the triangle o1ac, from this triangle, that is o1a and c, we know that cos alpha is equal to, what will be the value of cos alpha here? So so this angle will be alpha, so cos alpha will be equal to o1a upon o1c. And similarly for this triangle, this will be cos theta will be equal to cos theta will be equal to o2b upon o2c. So therefore we can write that omega 1 by omega 2 is equal to o2 cos theta divided by o1 cos alpha. So what we can write here is that, sorry, here o1c and o2c, o2c cos theta and cos alpha. So what is o2c cos theta? So o2c cos theta is nothing but o2b. So here I can write that is o2b. And o1c cos alpha, what is it? So o1c cos alpha is o1a. So here I can write o1a. So here you got the velocity ratio, that is omega 1 by omega 2 is equal to o2b divided by o1a. Now we have got the equation, that is omega 1 by omega 2 is equal to o2b divided by o1a. Now we'll consider the two similar triangles, that is these two triangles are very similar. So these two are right angle triangles. So here the ratio of, that is o2b by o1a, so the ratio is o2b by o1a. We can write this similar to o2, we can write it this very similar to, we can write this very similar to new triangles which we can form by connecting O1 and O2. So if I connect this O1 and O2 here, so there will be a angle, sorry, there will be a point that will call it as P. Now we have formed new triangles here. So this is a line, so and these are the triangles. So this point is called P, this is O2, and this is O1, and here there is B, and here there is A. Now we are considering that instead of O2B and O1A, we can write O2P, O2P and O1P. Instead of this ratio, we can write this ratio. So our equation will become similar like O2P divided by O1P. So our equation will be omega 1 divided by omega 2 is equal to O2B by O1A is equal to O2P by O1P is equal to PB by AP. So from this we can conclude that the angular velocity ratio is inversely proportional to the ratio of the distances of the point P from the center O1 and O2. So if it is desired that the angular velocities of two gears remain constant, the common normal at the point of the contact of teeth always passes through the fixed point, and the fundamental condition is the law of gearing which must be satisfied while designing the profiles of teeth for gears. So this is the law of gearing. Now we'll see the second topic of today's section, that is characteristics of involute and cycloidal action. So what are the characteristics for involute and cycloidal action? So before that, so cycloidal and involute teeth forms. We will see various comparison for cycloidal and involute teeth. So I will draw just a comparison, that is cycloidal and involute teeth. So this is cycloidal and involute teeth. So let's start the comparison. So first point here, that is pressure angle varies from maximum at the beginning of the engagement, reduces to 0 at the pitch point, and again increases to maximum at the end of engagement, resulting in the smooth running of gears. So this result in smooth running of the gears. In involute teeth, the pressure angle is constant. So here the pressure angle is constant throughout the engagement of teeth, and this results in smooth running of the gears. So this also will result in smooth running. So here the first point is about the pressure angles. The second point is it involves double curves for teeth, epicycloid and hypocycloid. This complicates the manufacturer. So it has double curves for manufacturing. So that is epicycloid and hypocycloid. So it complicates the manufacturer. It involves the single curves for the teeth, resulting in simplicity of the manufacturing. So it has single curve. So simplicity in manufacturing. So the second point was related to manufacturing. So this point was related to manufacturing. The first point was related to pressure angles. Now third point, so it involves third point is that owing to the difficulty of the manufacturer, these are costlier. So these are costlier, and as these are simple to manufacture, so these are cheaper. So the third is price. Third point is price. Then the fourth point is exact center to center distance is required to transmit a constant velocity ratio. So exact center distance is required to transmit a constant velocity ratio. So the center distance is required exact. So a little variation in center distance does not affect the velocity ratio. uh, no effect or no effect for little variation. There is no effect here. There is a much higher effect for transmission of velocity ratio. So this fourth point was for transmission of velocity ratio or center distance, you can call. Then the fifth point is the phenomenon of interference does not occur at all. No interference. So interference doesn't occur here, but interference can occur if the condition of minimum number of teeth on gear is not followed. So if minimum number of, so this will discuss about the interference in the next coming lectures. What is the interference and what is the minimum number of teeth? So minimum number of teeth of gear is not followed. Then the sixth point is that the teeth having sprayed flanks and thus are stronger. So it has spreading flanks. So this teeth has spreading flanks. So thus they are stronger. So this teeth have radial flanks. So these have radial flanks. So thus are weaker as compared to the cycloidal form or for the same pitch. So these are weaker and these are stronger. Then the last point, the seventh point, that is in this convex flank always has contact with concave face, resulting in less wear. The two convex surfaces, so here there are two convex surfaces are in contact and thus there is more wear. So here there is a convex flank and concave face. So flank and face are convex and concave. So there is less wear here, while so this one is convex and another is concave. So the wear is less, while uh, here in involute the wear is more. There is only one face, so here the wear will be more. So here the wear will be more and here the wear will be less. So these are the main 7 points for the comparison of cycloidal and involute tooth forms. Now, so what we have discussed today. So today we have seen the law of gearing, in which we have considered two teeth gears and their centers, and we have seen the law of gearing. In gearing, our main goal is to transmit the velocity, so the velocity ratio should be equal. So that is the velocity v1 cos alpha should be equal to v2 cos alpha. So this is the velocity law of gearing, what the law of gearing says. So from this equation we have by substituting various values and taking different triangles, we have come to the conclusion of us many forms of this law, and we have converted the velocity into angular velocity also, that is omega 1 by omega 2. Then we have seen the difference between two of the different teeth, that is cycloidal teeth and involute teeth. So as I have shown here, the cycloidal teeth here has convex and concave shape, while the involute teeth has just convex shape here. So these are the two types of teeth and what are the various difference between them. So now in the next lecture of this chapter, that is that it will be a third lecture for this chapter. So we will see in next lecture interference. So what is interference and undercutting? So this we'll see in the next lecture. So these are the topics we'll see in following lectures one by one. So thank you very much.